one function that's really helpful is to be able to convert back and forth between polar and rectangular coordinates. And if you think of a coordinate, let's say, for instance, that we have this point right here, and we have it r comma theta, all right? So essentially what would happen is that we would have a radius r, and then we would have an angle theta, and we could just use some right angle trigonometry to be able to determine what the coordinates are in Cartesian. And so we know that if this is x and this is y, we know one relationship, the Pythagorean theorem, x squared plus y squared equals r squared. And we also know that x would be equal to r cos of theta, all right, since the cosine on the unit circle represents the x coordinate, and then we just multiply by r for the distance, and then y would be equal to r sine of theta. And one thing to remember is that the tangent of theta is equal to x over y. And so if I took the inverse tangent of x over y, that could find theta for us. So these are four important formulas to help us convert back and forth between rectangular and polar coordinates. And they're given up here. I just wanted to show everybody how those coordinates are derived. Okay, so these are ones that you want to memorize. Make sure that you're good with them, or at least you can derive it using what we just showed below. So a couple examples, all we're going to do is we're just going to convert back and forth between rectangular and polar. So let's say we have the Cartesian coordinate, and it's 1 square root of 3, and we would convert it to polar. All right, so one thing we know is that x is 1 and y is square root of 3. And so if I wanted to figure out what r was, r squared is going to be equal to x squared plus y squared. And r is going to be equal to 1, or r squared, excuse me, 1 squared plus the square root of 3 squared, which is going to be r squared is equal to 4. And be careful, because r is going to be equal to plus or minus 2. Now, after we figure out theta, we're going to figure out which r we're going to use, either positive or negative. And what could be helpful is for us to plot the point to start with. Okay, so we have 1. We know the square root of 3 is 1.7. So it's probably going to end up like right about here for our point. So we know it should end up in quadrant 1. Now, theta is going to be equal to the arctangent of y over x, which in this case, we know that theta is going to be equal to the tangent of, or arctangent, excuse me, of y, which was the square root of 3 over 1. And we clearly know that that's the square root of 3. And we know that the arctangent of the square root of 3 is going to be 60 degrees, or pi thirds. All right. Now, if you don't know that, then make sure that you go back to your basic trigonometry and make sure that you're okay with your inverse tan stuff. Okay. So the coordinate that we have is that if we have xy is equal to 1 comma root 3, it should be a 3, excuse me, that means that in r comma theta, that's going to be equal to either plus or minus 2, but something pi thirds. And I think clearly everybody could see that it has to be positive 2 for it to end up in quadrant number 1. Okay, so if this were pi thirds, so that's what you're going to do, is you're just going to plot them both. If it were negative 2 and root 3, it would end up here. Okay, and that's not the one that we want. So it has to be positive 2 pi thirds. All right, so so that's the easiest way, I think, to be able to determine what you're going to use, either the positive or the negative r. Okay, a second example. So we have negative 2 roots of 3 divided by, or negative 6, excuse me. Okay, same thing. So we're going to have negative 2 roots of 3 square plus negative 6 square is equal to r squared. Right? And so if I go through and evaluate that, that's going to be 36. And we know that 2 times the square root of 3, that's going to be 4 times 3, which is 12. So we get 12 plus 36, which is 48, which is r squared. So that means that r is going to be plus or minus 4 square roots of 3. Okay, we're going to hold on to that. We're also going to plot the ordered pair. So if I plot the ordered pair, negative 2 roots of 3, negative 2 times 1.7, about negative 3.4. All right, and then down 6. And regardless, we know that it should end up somewhere in quadrant number 3. Okay, so that should be helpful for us as we go through. Right? Now, the other thing that we have to be cognizant of is trying to figure out the angle. And we know that theta is going to be the arctangent of y over x. So that's negative 6 over negative 2 roots of 3. Right? Or that's going to be the same thing as tan minus 1 of 1 over the square root of 3. Right? And again, we want to go back to our basic trigonometry. And remember that that theta is going to be 30 degrees or pi 6. Okay. Now we have to determine whether r is going to be positive or negative. And I think it's pretty obvious that the only way to get to, like if, for instance, if we were to go positive 4 roots of 3 and go, it would end up here. But if we ended up going negative 4 roots of 3, and that's going to be somewhere almost off the page that we have, and go pi 6, okay, that would certainly be feasible. Okay, so it looks like that the angle that we want, r comma theta, or excuse me, the radius that we want is going to be negative 4 roots of 3 comma pi 6. All right, and that's going to be our ordered pair. All right, now if we want to go the other way and convert into Cartesian, it's actually a lot easier, because remember we said that x equals r cos theta, and so in this case we have r is equal to 2 and theta is 2 pi thirds. So we just substitute. So 2 cos 2 pi thirds. And we know that the cosine of 2 pi thirds, and we know that the x coordinate 2 pi thirds is going to be in quadrant number 2. And so if we just remember our basic trigonometry, 2 pi thirds should end up being the square root of, 1 over 2. All right, so this should end up being 2 times negative 1/2 or negative 1 for the x coordinate. And we also remember the y is equal to r sine of theta, which is going to be 2 sine of 2 pi thirds. And we know that that's going to be the square root of 3 over 2. So this is going to be 2 times the square root of 3 over 2. All right. And again, if you're not sure of these values, what you want to do is you want to go to a unit circle and look these values up. Okay. At some point should have been in pre-calculus, you should have these memorized. Okay. But just in case you don't have them memorized, all right, you want to make sure that you have a unit circle so that way you can evaluate the exact values. Clearly, that's going to be the square root of 3. And so in terms of x, y, this is going to be equal to negative 1 square root of 3. All right, and that's going to be our Cartesian coordinate. And then finally, one last example. So we have 4 comma 3 pi. So we know that x equals r cos theta, or in other words, that's going to be 4 cos of 3 pi. We know that the cosine of 3 pi is actually coterminal to cosine of pi. All right, and if you don't trust me, just go into a unit circle. We know that this is 2 pi, and then if we go one more time around, that's going to be 3 pi. Okay, and we know that the cosine of pi is negative 1. All right, so this just becomes 4 times negative 1, which is negative 4. And we're going to do the same thing for the sine function, except the sine is going to be the y coordinate. So y is going to be r sine of theta. And that's going to be 4 times the sine of 3 pi. Again, the sine of 3 pi is coterminal with sine of pi. This is 4 sine of pi. And right here, we can clearly see that the y coordinate is 0. Okay, so that means we get 4 times 0, and we just punch that in our calculator, and we get 0 for that. I copied the 4 over, should be 0. All right. And so that means that in terms of x and y, our coordinate is going to be -1, 0, okay, as an ordered pair. All right, so that's how we convert back and forth between Cartesian and polar coordinates. Okay, it's not too difficult. It's almost like a pre-calculus problem because it just requires you guys to be pretty good at trigonometry. All right, so in the next section, what we're going to do is we're going to take a look at how we can graph functions, both with technology, but also how to utilize just analytic methods and convert back and forth between polar and Cartesian sorts of equations and plot them.